Alright, in this video we're going to be talking about the area of a shaded region. So you're going to have a big shape, and part of that is going to be shaded. You just want to find the area of the shaded part. So to find the area of the shaded region, you're going to subtract the area of the whole shape and the area of the unshaded part. Sometimes you can directly just find the area of the shaded part, but most of the time you're going to just have to take away the part that you don't want to include. So looking at this shape, we have a square here, and then this unshaded circle in the middle. You find the area of the square, and then take away this unshaded circle, it would leave you with the leftover parts on the outside of that circle, or the shaded part. That's the whole idea here. We're going to find the area of the entire thing, and then take away the part that we don't want to include, the part that's not shaded. So we're using area, which means we're going to rely a lot on these formulas. So I'm going to try to find the area of the entire shape here, which is just one big rectangle, and then subtract out the part that I do not want to include. That would leave me with that blue shaded area on the outside of the square. So I'm going to use length times width twice here. Length times width for the entire rectangle is going to be 8 times 10, or 80. So that would be the entire area of this whole thing. But I don't want the whole thing, I only want the unshaded part, so I'm going to take away this part, which means I need to find the area of that and then subtract it. So the area of that part is going to also be length times width, or 5 times 5, or 25. One last step, 80 minus 25, find out that the leftover part is 55. We're talking about area, so we'll just call that unit squared since there's no units actually given to us. We're just going to say whatever those units are, they're going to be squared. In example 2, I have a square. It's 20 by 20. So I'm going to find the area of that whole thing. That's length times width, for 400. That's just 20 times 20. Again, that's including more than I want to include. I just want to find the shaded part, so I'm going to take away this unshaded circle. Now I want to find the area of that circle, which is pi r squared, and the radius is what I'm given. That 8 is going halfway across the circle, so I can just directly plug that 8 in here. Pi times the radius of 8 squared. 8 squared is 64. 64 times pi is 200.96. So I'm going to do the whole area of 400 minus the unshaded part that I want to take away, and that leaves me with 199.04 units squared. That's the leftover blue section after you take away the unshaded circle. Whoops, those did not come out how they're supposed to. Hopefully on your paper that looks okay. That's supposed to be a circle going around the smaller circle. So we have the shaded circle. That has a radius of 7. And then this unshaded circle in the middle that has just that radius of 4. Alright, so we're going to find the area of the big circle using pi r squared, or pi times 7 squared, or pi times 49, which is 153.86. The circle in the middle has a radius of 4, so we're using the exact same formula. Pi times the radius, this time is 4 squared, which is 50.24. The area of the entire thing, the red circle that I drew there, is 153.86. The problem is that includes this circle in the middle, the blue one that I just shaded there. I want to take that away though. So we can subtract that out. Subtract these two numbers tell us that the leftover part is 103.64 units squared. One more that also didn't print out correctly. With the circle going around that triangle, the circle is shaded except for the triangle. which means I'm going to find the whole area of the circle, and then take away the part that I don't want to include, which is that triangle. So we're going to need to use two formulas here. Area of a circle, pi r squared. Area of a triangle is 1/2 base times height. We find the area of each of those parts and then subtract those two. The radius is 8. This distance goes from the center of the circle to the edge of the circle. That is the radius. So we're going to plug in 8 for the radius in this equation. And we're going to find out that the whole area is 200.96. That's the area of the circle. The area of that triangle, we're going to use the base and the height of that triangle, which are both 8. We'll do 1/2 base times height. Find out that the area of that is just 32. Final answer is subtracting those two to get 168.96. Same idea for each of these, even if it gets more complicated. So I'm going to go over one from the back because it is especially complicated. I'm going to go over the very last problem. We're trying to find the area of just the shaded part, which if you first start out looking at that question, it's like, how am I going to ever find the area of just that shaded part? But if you find the area of the big rectangle, and then take away these three sections, that leaves you with that shaded part. So, area of a rectangle requires a length and a width. So going all the way across the top, it's 1, 4, and 1. That's a total of 6. Going all the way across the left side, that's 2, 5, and another 2, that's 9. The area of the entire thing is 54. Something that includes these unshaded parts that I want to take. So, I'm going to find the area of this circle first. Notice I didn't call it a half circle. It's 2 half circles. I can just put that together and form one full circle. Thinking about that full circle, it's a diameter of 5. To find the area of that circle, I'm going to use 1/2 pi r squared. 5 is going all the way from one end of the circle to the other. I don't want to use 5. I want to use half of that. I'm going to divide that by 2 to find out that the radius is 2.5. So I do 2.5 squared times pi, and that tells me that the area is 19.625. If you'd like to divide that by 2 and then put the area of each half circle in there, you could. But remember, this and this are just this and this put together. So we really have that entire area. So we're going to do 54 minus 19.625. And then we're also going to subtract out this half circle. That's actually just a half of the circle. I still need to use the area of a full circle. I'm just going to cut that final answer in half. So the radius of that circle, the entire way across the circle is 4. Halfway across has got to be 2. I'm going to do 2 as the radius. 2 squared is 4 times pi. So the area of a full circle that looks like that would be 12.56. I only have the bottom half of that circle. The area of that is 6.2 feet. So I have 54 as the whole area, minus this circle, minus the last half circle there, minus the 6.28. The final answer of 28.095 centimeters squared. No matter how complicated they look, it's really just about breaking it down into the big shape and then taking away these smaller parts.